Hello beautiful people, this is Miss Beeching here. Today I'm going to show you how to write a one-step equation. So we're going to take some patterns and situations and turn them into an equation. These equations are one step, which means that they only have one thing other than the variable in the equation. So the first pattern we're going to look at is what we call a matchstick pattern, and these are pretty common ways of practicing patterns. Just imagine each of these lines is a matchstick, and we're going to pretend that my drawings aren't terrible. And this pattern has many steps, but I'm only going to draw 3 of them. So this is the first 3 steps of the pattern. And you can see how we go from 1 pentagon to 2 pentagons to 3 pentagons. And the first thing we need to do is think about what is changing in this pattern. Well, we know that we're changing steps in the pattern. So let's call this step 1, step 2, and step 3. And between each step, we know that the number of matchsticks is changing. So we start off with 5 sticks, and then we have 10 sticks. So we have the 5 that we started with plus these 5 new ones. And then in the last step, we have the 5 that we started with, the 5 that we added in the second step, and another 5 on the end. So each time we go up a step, we're adding 5 sticks. All right. So we've noticed what's changing in the pattern. So let's move on to the next part. We're going to define the variables, and to do that, we're going to rewrite this number of sticks in a bit of a weird way. I'm going to say that there's 1 in chunkier writing. I'm going to say that there's 1 lot of 5 sticks in this first step. In the second step, there's 2 lots of 5 sticks. And in the third step, there's 3 lots of 5 sticks. And you might notice how we've got one part here that doesn't change, and then we've got this other part that does change, and that is a variable. So let's define that variable, and I'm going to call it A. You can call it whatever letter you like, but I'm going to say A is this number that's changing, and you notice how it matches with the step number, or you could say it's the number of pentagons, whatever floats your boat. So I'm going to call this step number or the number of pentagons. So we've got 1 variable, but we need 2 to write an equation. So let's have a think about what the other thing that's changing. We're changing the steps, and we're also changing the number of matchsticks in each step of the pattern. So let's call that B, number of sticks in that step. Cool, so we know that. And we can see in these parts here that we're always doing A times 5. So let's write that. So we're saying A times 5, and that gives us the total number of sticks. So that equals B. And we can obviously rewrite this without as much writing. We could write it like 5A equals B. These two are interchangeable. This is the quicker way of writing it though. So woo, we've got our equation, but we need to check that it's correct. So we just did that step. Now we're going to move on to the last step. And if you haven't done skill 4.3, make sure you check on that one because I'm going to go through this pretty quick. But we're going to double check our answers correct. And to do that, I'm just going to pick any one of these steps. It doesn't matter which one. Let's say I pick step 3 to test this pattern out with. So I'm going to take this step and say, all right, well, I know that A, the number of pentagons is 3, and B should be 15 sticks. So let's put A equals 3 into our equation and check. So 5A equals B. So 5 times 3 equals B. And we know that 5 times 3 is 15. And that's what we should get. matches, so we know our equation's correct. Hooray, we've written an equation. Let's try a different kind of pattern. This time it's going to be a number pattern. It's going to be pretty much the same thing but without the pictures. I should come up with a quicker way to rub this out, but that's fine. Rub, 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 rub. All right. So this next number pattern is going to be something like this. So let's go 7, 14, 21, 28, etc. Dot, dot, dot. Keeps going forever. So let's follow the same process. So let's notice what's happening, what's changing. So we're starting off with 7, and then we end up with 7 plus 7, and then 7 plus 7 plus 7, and then 7 plus 7 plus 7 plus 7. And just like we did before, we could rewrite this as 1 lot of 7, 2 lots of 7, 3 lots of 7, 4 lots of 7. And again, we notice that one part's staying the same, which is the timesing by 7, and one part is changing. So that part that's changing is one of our variables. So let's call this C. And this number, 1, 2, 3, 4, this is the step number because this is the first step, this is the second step, third step, fourth step. So I'm going to call this the step number. It's kind of a weird, vague variable, but then this is a weird, vague number pattern that doesn't really relate to reality. So it's okay to be a little bit weird in this part. And then our other variable is going to be the number that's in the pattern, 7, 14, 21, 28. So the number in that step. And again, it's a bit vague, but this whole pattern's a bit vague. So now we've got our variables, and we're going to write our equation. And we know that in the pattern, we're going our variable, the step number, times 7 every time. So we could say C times 7 equals the number in that step. Or if we write it quicker, we can say 7C equals D. And then once again, let's check our answer by substituting into it. Again, we can pick any step. I'm just going to pick this step here. So I'm going to say that D is 21. C, this is the third step in the pattern. So let's substitute in. So we know that 7C equals D. C is 3. And 7 times 3 is 21. Hey, that matches. Woohoo! Our equation is correct. Winning! Cool. So we can do that with patterns, but sometimes it gets a lot trickier when we are using a worded situation, and a lot of people get tripped up by these. So let's practice one, and then you're going to try and do one yourself once I finish wrapping this thing out. And the tips that I'm going to give are a little different for this one, but we're going to run through it. So we've got this situation, and I'm going to quickly screenshot it and whack it in. So we're saying Todd has $200 and a pair of runners. Write an expression for the amount of change he would receive. So usually with a worded situation, the first thing that I like to do is to find out the two main pieces of info, or the two unknowns, the variables. Actually, it's a bit chunky. I want to make that smaller. Otherwise, we won't have room. And while I'm writing this, have a think. What are the two unknowns in this situation? And so in this case, the two unknowns are the amount of change he would receive, because we don't know how much that is, and the amount of change he gets depends on how much the runners cost, right? And until we know one of them, we can't work out the other. So those are our two unknowns, or our two variables. So let's call E the cost of the runners. And I'm going to specify that's in dollars. And the F is the cost. Nope. It's the amount of change he gets, because the amount of change he gets depends on how much the runners cost. And that's in dollars as well. Cool, so we've got some variables now. That's really helpful. Now, sometimes some of you will be able to go straight to the equation, and if you can do that, go for it. If you're still having trouble at this point, this is a thing I find a lot of students find very helpful. So we're going to imagine that we know one of these variables and then pretend to work out the answer. And usually you'll know how to do that. So if we pretend we know the cost of the runners, and we can pick any number we want. How would we work out the total change? So have a think about that. If you knew how much the runners cost, and in this situation, let's pretend that the runners cost 40 bucks. How would you work out the total change? Have a think about that. So to work out the change, we'd say, all right, well, he's got 200 bucks, so let's take away that $40, right? So the amount of change he gets, F, would be 200, take away the $40. And right there, you've just written the first steps in the equation. So now let's just change that into an equation. All we need to do is change that 40 into our variable. So if you're ever stuck in trying to write an equation, just try to pretend you know one of the pieces of information and see how you would work it out. Usually you can get the answer that way. So we're saying that F equals 200, take away, instead of 40, we're going to say that it's the cost of the runners. And that's our equation. Easy peasy, done. And of course we should check that our equation makes sense, so let's really quickly substitute into it, and we can use that $40 again. So let's say that E equals 40 bucks, and we're going to test our equation out to see if it makes sense. So if we think about it, if the runners cost 40, our equation should say that we get $160 worth of change, which is what we get, right? Because 200 take away 40 is 160. And that sounds about right. So that equation is reasonable. We've checked it. Now, for you guys to practice, there is a problem in the gather section that I want you to try out. I'm not going to write the answer here, but I am going to post it up. And I want you to try and employ a similar method to what we just did for that worded problem, but for this problem here. Whoa. All right. Good luck. Have a go, and I'll see you next time.